expressions. What does rational mean? You can look through all of your examples and see that all of your examples are fractions. And so you have to know how to multiply and divide fractions. So here's, this isn't on your note paper, but here's just some fractions. Do you remember from just not whole numbers, but just numbers, how do you multiply fractions? Do you remember that to multiply fractions, you multiply numerator times numerator and denominator times denominator, and you reduce to lowest terms if possible? That's written on the previous page. The way you multiply fractions is numerator times numerator and denominator times denominator. You do not have to have a common denominator. That comes up from adding and subtracting. So this dot right here tells me that I need to multiply those. But before I try to multiply those, I'm going to reduce it as much as I can at the beginning, and that makes it easier at the end. So what number divides 8 and 26? 2 will go into that 4 times. 2 will go into that 13 times. What number divides 14 and 12? 2 again. 14 will go, 2 will go into that 7 times. 2 will go into that 6 times. And then expand. I have a 4x to the third power. And I have a 7y to the fourth power. And I have a 13xy 6x squared. So, what cancels? Now, my previous class was canceling way too much. 1x cancels with 1x, and 1y cancels with 1y, and this 1x cancels that 1x, and this 1x cancels that 1x, and so we have canceled out a lot, and so there's one other thing we can cancel. I notice that these are both even numbers. So how many times does 2 go into 4? And how many times does 2 go into 6? So what's left after all of this canceling? 2 times 7 is 14, and I have 1, 2, 3 y's. 13 times 3 is 39, and I do not have any variables left on the bottom. This is multiplied and simplified. It's not solved because I don't know what x is equal to yet. I don't know what y is equal to yet. That's going to come up next week. We're going to work on that. Questions? What does a binomial mean? 2. What's the first thing you do on a binomial? Factor out a GCF. And so on this first binomial, what is the GCF? What divides both the 3 and the 6? 3, and they both have x's. They actually have x squared or higher. So out of this, I'm going to factor out a 3x squared, and so I would have x plus 2 left. What will factor out of this numerator? It's like a 4x. And so 4 divides into 4 one time. 4 divides into 4 one time. This is not just x. This is x plus 1. When you factor out a 4x, this is a 1 right here. Let's see. Our next term that we're going to look at right here, what factors out of that? x plus 1. X divides into x one time. What factors out of x plus 2? Now that I have it all factored out, I want to cancel out everything I can. The x plus 2 on top cancels out the x plus 2 on bottom. X plus 1 on top cancels out an x plus 1 on the bottom. This x will cancel out that x. So, what's left? 3 times 4 is 12x squared. What do I have left on the bottom? 6. But you got to check your answer. Is that reduced completely? Not quite, because 6 will divide into 12. How many times does 6 go into 12? And so this is my final answer. I need to check and make sure my final answer doesn't reduce anymore. So when you have a binomial, you factor out the GCF. When you have a binomial, you also look for the difference of two squares. Right here in example number 3, this is the difference of two squares. Some people were having difficulty factoring that, and this helped them. This is equal to 0x minus 9, because some people were a little bit better at factoring trinomials than binomials, so I'm writing this out on my scratch paper. And so the factors of -9 are 1 and 9 and 3 and 3. If this is negative, the signs have to be different. Would that add up to be 0? This would factor into x minus 3x plus 3. That is your difference of two squares pattern. Over here on the sideboard, I have put some of your difference of two square patterns to help you kind of get that down better, because we will see that pattern a whole lot. So the numerator right here is x plus 3, x minus 3. This denominator is the difference of two squares pattern. 4 is a perfect square number. So this is going to factor into x plus 2, x minus 2, because 2 times 2 is equal to the 4, and the 4 is a perfect square number. This is the perfect square pattern. What factors out of this? When you take a 4x out of this, that's what you have left. Let's see. What factors out of this? When you have it completely factored, then you cancel everything that you can. X minus 2 cancels x minus 2. X plus 3 cancels x plus 3. Is there anything else that will cancel? 4 and 6 both divide by 2, so if I divide these by 2, 4 divided by 2, 2 times, 6 divided by 2, 3 times, and so that cancels out. Okay, what do we have left on the top? We have a 2x and an x minus 3. On the bottom, we have a 3 and an x plus 2, and it's traditional to put your whole numbers in front of the term that has a parentheses. Look at your final answer. Will anything reduce? Some more. Is that it? That is completely reduced. Trinomials, again, you always start by factoring out your GCF, and then you have to factor difference of two squares if you have them, and then you have to factor your common terms. And it looks like I lost the next problem. And so the next problem is x squared plus 2x minus 3 what factors out of this right here? What's the common factor right there? You see they all have a 4? And so this is x squared plus 2x minus 3. I'll get back to that in a minute. This factors out a, 4. 4 will go into 8 2 times. What will factor out of this term right here? Do you see any difference of two squares? Do you see right here, this is the difference of two squares because this is minus and 4 is a perfect square number. So this numerator right here factors into x plus 2, x minus 2. We don't have any more difference of two squares. The rest of them are trinomials with a coefficient of 1. So to factor this one right here, you multiply the first number times the last number, and you get a -3. The factors of -3 are 1 and 3, and I need the factors that add up to a +2. If I put the signs in there like that, this numerator right here factors into x minus 1, x plus 3. That's this numerator right here. This denominator right here has a 4 out in front. If you multiply the first number times the last number, you get a -2. The factors in -2 are 1 and 2. If you put the signs in with a -1, this factors into -1, x plus 2. That's what this term right here factors into. This term right here, multiply the first number times the last number and you get a -6. Factors of 6 and 1 and 6 and 2 and 3. If you put the signs in like that, it adds up to the x. So this factors into x minus 2, x plus 3. Now it's all factored. This part right here is all the factors. What will cancel out? My canceling pencil, let's see. An x minus 1 cancels an x minus 1. X plus 3 cancels an x plus 3. An x plus 2 cancels an x plus 2. X minus 2, x minus 2. And so all of that cancels out to 2 over 4. But what is 2 over 4 equal to? So all of that cancels out and reduces to 1/2. For our next problem, the first numerator is 2x to the third power minus 5x plus 3. That's my first numerator. I'm going to factor that. I'm going to go over here to my scratch paper and factor that. This does not start with a 1x squared. I need to multiply my first number times my last number, and I get a 6, a positive 6. The factors of a positive 6 are 1 and 6, and 2 and 3. Now, if I put the signs in like this, that can add up to a -5. If I put the signs in like that, that could add up to a -5. How do I know which pair to use? Will this pair multiply to a positive 6? This is a positive 6. Does that multiply to a positive 6? Does that multiply to a positive 6? This is the pair that I need. But I have to factor by grouping, and this, I believe I copied off of my paper wrong. Wasn't that a squared to start with? And so this is minus 2x minus 3x plus 3. Can you factor by grouping? What factors out of this pair? I factor out of 2x out of that, I have an x left. 2x divided by 2x is 1. I'm going to factor a 3 out of this pair, but if this is negative, I'm going to factor out a negative. So this is going to be x minus 1. X minus 1, 2x minus 3. That's the numerator. That's what the numerator factors into. So over here for problem number 5, the first numerator is x minus 1, 2x minus 3. Did I copy it down right? Yes. In problem number 5, x to the third power minus 2x squared minus 3x, that's the first denominator. What am I going to factor out of that? See, they all have x's. Then this part is a trinomial with the coefficient of 1. 1 times -3 is -3. The factors of -3 are like that. If the signs are like that, it will equal to -2. This is going to factor into x plus 1, x minus 3. That's my first denominator. So that is going to be x plus 1 minus 3. My next numerator is like this. First times last is 2. The factors of 2 are 1 and 2. Everything is positive, so this is how it is going to factor for my the next numerator. This is x plus 1, x plus 2. Okay, another hard one. 2x squared plus x minus 6. Multiply the first number times the last number. And you need the factors of 12. I need the factors of 12 that add up to 1. If the signs are like this, can I do the shortcut? Can't do the shortcut because this is a 2, not a 1. So we have to do 2x squared minus 3x plus 4x minus 6. I'm replacing the x, the 1x, with those two terms so that I can factor by grouping. This factors out an x. This factors out a 2. When you factor out an x, when you factor out a 2, 6 divided by 2, this gives me 2x minus 3x plus 2. My last denominator is 2x minus 3x plus 2. When I have everything factored out, then I start looking for things that will cancel. The x minus 3 cancels the x minus 3. X plus 1 cancels the x plus 1. X plus 2, x plus 2. So we have an x minus 1 left on top, an x and an x minus 3 left on bottom. This is your final simplified answer.